So before break, we introduced Duban-Watson test. This test can tell us if autocorrelation exists or not. If there is autocorrelation, we cannot use regression model. We have to add some variable or do some data manipulation. For example, take logarithm, take difference. The purpose is to eliminate autocorrelation. Okay, so now let's look at another example. This is example 8.5. 8.5. Generalized difference. Try to find the page number. So it is on page 355 in the textbook. So what we are going to do with this data, again, this data is a sales data, the same data we used before. Okay. If we are going to use the regular regression, so this is the sales income. If you conduct a linear regression, you put sales dependent variable, income independent variable, okay? And you check out Duban-Watson test under statistic options, and then you will get this result, okay? So now let's analyze this result. So Duban-Watson test 0.63, okay. And this number smaller than DL is 0.97 when you have sample size 21, K equal to 1. Because DW smaller than DL, we conclude it is has a positive correlation among the errors. Okay, so autocorrelation exists, so we cannot use the model. Although the model, the p-value smaller than 0, we cannot use the model because it is violate one of the conditions for regression. Okay, so then what do? We do the generalized difference. So we do y minus y lag 1. So for example, we do this number, this is y minus yt minus t minus 1. So we do this one. So this number subtract this number. Okay, I will show you in Excel. This is 8.5. So this is the data. What we do, we are going to do the difference. So I'm going to copy the data and do the demo. So to be consistent, I want to maybe put the data, okay. So what I want to do, so this is my Y, sales is Y, and this income is X. Sometimes I do not distinguish capital letter, small letter, okay. It's just dependent variable, independent variable. So what I'm going to do, I'm going to produce YT minus YT minus 1. So specifically, I'm going to do this number. For example, this is 1977, the sales value for 1977, minus the sales value for 1976. The result is YT minus 1. Okay, and then copy down. Do the same thing for XT minus XT minus 1. Oops. Okay, so you are going to do income in year 1977 minus income for year 1976. And then copy down the formula. Okay, so this is your new Y, your new X. Copy this new Y, new X into SPSS. Okay, and you will get this. This is your new Y, new X. Okay, and then perform the regular regression. And then this is the output. Check our Duban-Watson test. So you get the output here. So in this output, you have a Duban-Watson test 1.124. Okay, 1.124. And then where is your DWD alpha 0.05, sample size equal to, so for this sample size, you actually have how many? 20, n equal to 20 for this data, n equal to 20. K equal to 1, so your DL DU. Okay, so I have to go way back, DL DU. DLDU, K equal to 1.2, 1.41. Okay, one sample size equal to 20. Where are I? Okay. Why it not register? My pen does not work. Maybe I will just type. So you know DL 1.2, DU 1.41. So our number 1.12 smaller than DL 1.2. Let me see. Duban-Watson test. Coefficient. Looks like this DL 1.2. This Dubon-Watson test I get. Let me check. So 1.12 compared to DL, DL is 1.2. So this number is still smaller than DL, then there is correlation. There is correlation. So you cannot use this model, although it said p-value smaller than alpha here, because Dubon-Watson test is smaller than DL. Okay, let me double check DL just on safe side. I'm checking the number for DUDL. (1.2) is DL, okay, and DU 1.41. Okay, so you cannot use the model because it has autocorrelation. So that is for regression with time series. When autocorrelation happens, you need either to add additional variable or do the logarithm, do the difference, etc., until you do not have autocorrelation so that you can use the model. The key formulas listed in this chapter listed here, okay, at the back of the textbook. Okay, so any questions? So that's conclude chapter 8. Chapter 8. I will just to stop recording because I'm going to start a new topic, logistic regression.